Hey, hi. In this video, I'm going to show you how to host Istio Service Mesh on Amazon EKS or AWS EKS. So as you see in this PPT depicts my demo. Here, as you see that, we're going to create a VPC that is in AWS. Within the VPC, we're going to create a subnet that is required to host the Amazon EKS cluster. So the Amazon EKS cluster will be having managed node groups as well. So on top of this one, so how we can host the Istio Service Mesh layer so that it actually helps us to govern the service to service communication or from user to service communication. Okay, so basically here I'm going to help you to walk through like how to deploy the required components of Istio Service Mesh on Amazon EKS cluster, and then how we need to basically write the manifest file which will actually govern the required traffic between service to service communication, and how does the the user from internet can reach to the services. Okay, so as you see here, so we're going to see that how we can create a required foundational the infrastructure that is required to create a Amazon EKS cluster. That is, we will see how to create a VPC, the component with using Terraform. On that VPC we're going to see how to create the subnets, right? So then on top of the VPC, how to attach the internet gateway so that we can communicate to the internet and vice versa. And we will see that how we can deploy a application load balancer so that the communication from the internet can go through the the application load balancer, which is actually manages the the which actually load balances the request that will come for service request purpose. Yeah, now on top of the EKS cluster we will see how we can deploy the required the components of Istio Service Mesh, which is generally includes like Istio base and also the Istio, the Istio D actually. So we have those two components. We see that how we can deploy that with using the Terraform as well. Now, once we have set these, once we have set the our EKS cluster with these components within the Istio Service Mesh, how we need to define the Istio gateway, how to define the virtual services, how to define the rest, the destination rule. So then under the hood we're going to see that how does the traffic from internet or basically from the users passes through the application load balancer through the internet gateway of the VPC, and it reaches the application gateway. Then application gateway has its own virtual services which defines to which destination how the traffic has to go on, and what is the the final application version it has to reach in, right? So as you see, if you follow the arrow mark here, the traffic from the internet flows through these components and reaches the respective service versions, right? So here the user might be expecting the service version 1, or he might be expecting the service version 2, right? So based on the the queries, the traffic will be routing to the respective service versions. So that is basically user to service communication path. So here, how does that Istio Service Mesh helps us to govern that traffic? Okay, so we're going to see that how we can define that and how we can deploy that on the EKS cluster. Now there is another scenario that, for example, say you want to see how does the service to service communication happens within EKS cluster and governed by Istio Service Mesh. So say that we're going to deploy another client service, or say like another client application that will talk to the this service, right? So the traffic will be forwarded through the virtual services, and in virtual service we will define the destination rules. In the destination rule we will have like what is the target service and what is the the version of the service, and on which port it has to reach in, what is the HTTPS protocol, right? So everything will be defined in the destination rule. Now in total, so this video will actually help you to understand how to host the Istio services with using the infrastructure as a code. So here we're going to use Terraform. We're going to define the lots of .yaml file, which is basically manifest file, which actually defines the Kubernetes objects on the EKS cluster, right? And we also practically understand how does this traffic flows in general. All right. So with that note, what I do is I'm going to take you to the my VS Code where I have where I have ready-made code here. So basically, I have created a repository called AWS EKS Istio Service Mesh. In this repository, we have these many folders, and these folders are meant to do particular object, particular basically task here. So before I walk you through these source code, let me take you to my AWS account first. So this is my AWS account where I am deploying that EKS cluster infrastructure. On that infrastructure, we are deploying the service mesh, and the service mesh is actually governing an example application, right? So we're gonna basically wrap that application into a Docker hub, Docker image, and publish that Docker image into the my hub.docker.com subscription. So I have this account. So with using that account, I'm gonna create an example repository called EKS Istio demo. So underneath this one, we're gonna publish the Docker image of our application, that is demo application. So this is where the tag of that particular application will be. All right. So this is basically the background scenario, right? So where is my AWS account, where is my Docker hub? Now let me take you to the VS Code again. So here I'm going to walk you through the code here actually. So basically, so we're gonna do a quick walkthrough of these codes. What does this code is meant for, and how does that actually creates a backend infrastructure as well. And then later we're going to see the scenario of like how the service to service communication happens, and how the the user to service communication, how does it happens. All right. So with that being said, let me quickly walk you through the source code here. As I said, I have a repository called AWS EKS Istio Service Mesh. So I'm going to share this repository link in the video's description. You can find this repository link from video's description, and you can do from your side, very basically, you can actually learn the this particular demo with a hands-on experience. Now what I do is, let me quickly walk you through these folders first, then we're gonna do we're gonna go a bit deeper here. So here we have a 5 folders meant for different purpose. One is EKSTF. So as name says, so this is the folder where I have defined lot many .tf file, or basically Terraform files. These Terraform files are meant to spin up the foundational infrastructure. So here we are writing the infrastructure as a code with using Terraform. So I'm going to walk you through these files very quickly as well. So when you run this particular file from this particular folder, you're going to end up with creating the the EKS infrastructure at your AWS at your AWS account. So here this is what it folders does. Next one, so we have an example folder, that is example application folder. This is basically an example Golang application, and that Golang application is being wrapped as a Docker image with using this Docker file. So this Docker file defines how it has to construct a Docker image. So we are using you see that we are using the Golang base image. On top of that image, we are actually constructing the Docker image. So that's what this Docker file defines. If you want to learn more about the Docker file, how it has to be defined and how it can be used, do watch my previous video where I have declared, where I have explained you in depth about this one. For now, I'm gonna go very fast. So this is our Docker file, and this is where we are actually in. Okay. Now, so that is about my example application. What we do is we first complete the Docker image build and Docker image push. Then we're gonna go to the infrastructure. Then we're gonna go to the how to deploy the the components of the of the Kubernetes cluster. So for that reason, what I did is I have did a CD to this particular path called example app. So being within this example app, we need to run 2 commands. So anyways, to help you to understand how to run those commands, I have already documented those commands in the readme.md file, and this file will be available in the same repository link, which you can find it from there. So don't forget to change these values. That is your basically it's your Docker hub accounts handler or account name, and this is your repository, and this is the latest tag. Okay, first let's build the tag. I have already built previously, so let's do it one more time here in front of you. So it currently says that there is basically the indicates that Docker daemon is running. Okay, you might encounter these kind of errors for the first time when you are trying to do it. Okay, so why this kind of error happened is basically I have not enabled my Docker desktop, right? So I have a Docker desktop application I have not basically activated. That's the reason it is throwing the error, right? So when you have a Docker desktop application, and if you are not so if you are not activated this, you might see this kind of error, that is Docker daemon. Okay, so once you run this Docker engine, the Docker daemon actually will be started. In the sense, the Docker daemon is kind of an application through which you can interact with the the Docker application, and which will actually help you to deploy the the images and all. Yeah. All right. So currently when I activated this Docker desktop, now the daemon should be running. Again, let's run the same command. Now this should go through. Here you go, right? So now we see that it is actually working. So let me make you more visible. You see that since I have already built this image, so this time it is going very fast. But if you are trying to build it for the first time, it will gonna take us some time. So be patientful. Now once the Docker image has been done, you can see that Docker image available here. Yeah. So now we need to push this image to the Docker hub. Okay, so this is my Docker desktop. In the sense, this is local repository. Now we need to upload that image into the the hub, which is nothing but actually a server or a web application, that is nothing but upstream, right? So for that reason, we need to run the next command, that is docker push. And docker push, so basically it has a syntax like you need to give the your handler name or basically account name, then / repository name, and make it latest. Okay, so this, note that this repository is public repository, so you can also try to use it from your side. Now I'm actually pushing to this repository, and here you go. This is what it happens when you try to build your application image. Okay, so you see that it says already exists because I have not modified anything, so the image remains as same as it is. So you need to do these two steps to build an image and publish the image into the Docker hub. Okay, so for that reason, so remember that you need to have a Docker hub to do this particular demo, from your side. Okay, now let's go to the next part of the demo. Let me clear this off. So now we are ready with our application Docker image. I'm going to close this application. Now we need to have the foundational infrastructure. That is basically we need to have the, so we need to have the EKS cluster. Okay. So now what I do is, I'm going to go back to the diagram. So we will see that, we have so many infrastructure resources. First, we need to have a VPC where you can deploy the EKS cluster. VPCs are further divided into subnets. In the subnet, we're going to deploy the EKS cluster. So once you have a EKS cluster, within that, you're going to have the node group as well, so which we're going to see right away. Now, so as you see here, this is the folder where we need to do now. So basically, we need to go to that particular path. Yeah. So for that reason, let me go to the cd .. and let's do a cd to this particular path, that is EKS TF. So I'm going to go to this particular path, and from here, you need to run the Terraform commands, that is Terraform init and Terraform apply should be run from this command. Yeah. Note that in this demo, we are actually running this Terraform file from local laptop. But when you do it from the CI/CD tools like GitHub or Azure DevOps, you need to build the workflow for respective, the task, or basically you need to build the GitHub action pipelines in general. Yeah. So here, let me quickly walk you through these files. What is this file do, and what are all the resources we're going to create? Okay. I'm not going to go very deeper, but I'm going to give you a very glimpse of that. Okay. As we said, we need to have a VPC. So we are creating a VPC with using this particular command. So if I go to the subnets here, so we have a routes. You see that we have a lot many files. So let's go to the vpc.tf file. I have given the file name in a such a way that it actually does the same. Basically the file name tells you what is actually this Terraform file going to do. So here VPC is actually going to create a VPC for us. So in this one, we are using the CIDR block of this much, right? And it is actually creating a VPC for us. Now, once we have a VPC, we need to have a subnet. So the subnets are being declared in another file called subnet.tf file. So here we are creating a two subnets. One is called as a private subnet. Note that I'm using US West 2. As I said, we are using US West 2 region, right? So this is creates one subnet, and this is the another public subnet. So why we are creating two public subnet, two private subnet is because so that we distribute these subnet across the availability zone, so that we get a high availability across the zones. So we have a two subnets for private and two subnet for public. That's the subnet. Yeah. Now we also creating the independent component of the VPC, that is IGW. So here we are creating an internet gateway, because if you are AWS engineer, you might be know that so to communicate to and from the internet, you need to have an internet gateway attached to a VPC. Then only the traffic can go in and out of the VPC. So we are creating an internet gateway pointing to the VPC that we have created just now. Now we also need to have a NAT gateway, because we are keeping the pods in a private subnet, right? So and these pods need to be communicated to the internet, for example, say, right? So in that case, you need to mask the IP address of the private resources or private subnet resources. So in that case, the communication will go through the NAT gateway. So for that case, we are creating a NAT basically, and you see that we actually have the NAT gateway being created here. So it also depends on the internet gateway. So without internet gateway, it will not create. And this is deployed in a public subnet. That is, as I said, this NAT gateway will be kept in a public subnet, while the resources are basically the infrastructure which communicates through the NAT gateway will be sitting in a private subnet. So that is about the NAT. Okay, now next one. So next one we go to the we go to the routes, right? So if I go to the route, so we are creating the the route table here. So as you see here, we have a route for private subnet. We have a route table for public subnets. Okay, so we are creating two subnets, and you see that we also have the respective the route table association as well. In the sense, what we are doing is we are creating a two subnets, two route tables. One is mean for private subnet purpose. This is the one, and it has its own route. So when you say private route, you see that, as I said, if you want to talk to the internet, you need to go to the NAT gateway. That is what the route will be defined in a private route table routes. Similarly, for in the public subnet route, so here we have a route that is, if you want to go to the internet, you need to go to the internet gateway. That's what the route will be defined. So these route tables will be associated with the respective subnets. Say private subnets are attached to a route table of private type. Similarly, public subnets are attached to a associated with the public route table, like that. So that is the routes. So we have seen the route as well. Now let's go to the our main component. Okay, that is EKS. So let me go to the EKS. That is, this is the basically the Terraform file which actually creates the EKS cluster for us. So before you create an EKS cluster, you need to have the IAM role. So those IAM roles are being created here. You see that we are creating an IAM role. We are attaching a required policies to that IAM role, and then we are creating a EKS cluster. So here I am creating a EKS cluster of version 1.29. Remember that. And the VPC configurations are pointed to the those four subnets that we created, and then it actually depends on the policy. So this is very easy of creating the EKS cluster of version 1.29. Now remember that we have not created a nodes now. Let's see how are we creating a nodes on this EKS cluster. So for that case, we go to the next file, that is nodes.tf file. So in the nodes.tf file, again we are creating a node group. For that case, we also need an IAM role. That IAM role is attached with policies like the AWS managed policies, EKS work node policies, CNI policies, container registry policies, then SSM managed instance core policies. Okay, so with that IAM role with these IAM policy attached, we are using that IAM role to create a node group. So node group actually defines like how many number of the nodes that you need to have in the EKS cluster. Okay, this is basically kind of so you created a cluster which is actually a template. Within that template EKS cluster, you need to create a nodes where actually your workloads will be running. So here we are creating an EKS node group, and that is pointed to a cluster. This is a private node group, right? So you see that we are keeping the node group where we are keeping the node group in a private subnet, and that's why I said we are using the NAT gateway for the communication to the internet. Next one. So what is the instance type I'm using? That is T3 large, because T3 large is recommended for EKS cluster. That is a starting point, I can say. And then we have a scaling configurations. I'm keeping scaling configuration very minimum. That is desired state is 2, maximum is 2, and minimum is 1. Right? And then we have a labels like something like this, and we are attaching the basically we are making this resource dependent on those IAM role policies, so that I can attach IAM roles to this particular node group. So we created a node, we created a cluster, we created a node group. Now time has come to start the deploying the the Kubernetes objects here, right? So here we want to use Istio. So Istio application base Istio, like your the another application on the EKS cluster. Istio, I consider it as an independent application layer which runs across the the Kubernetes the infrastructure layer, and tries to manage the applications. Okay, now let's see how are we creating those Istio related components. Okay, now our cluster is ready. Now we need to start deploying the Kubernetes object need for Istio Service Mesh. So before that, we need to have a certain add-ons, certain pre-configurations. So one is we will have CIS driver add-on. So once the EKS cluster is been up and running fine, we're going to have the EBS CID, the EBS CIS driver will be installed, and the add-on version is this one. Remember that since I'm using version 1.9, which is latest one, so the add-on version should be equivalent to that. Okay, so you can explore the AWS document where you're going to find it that what is the add-on version of respective driver. Right, so that is the information about the CIS driver add-on. So here EBS CSI driver. Now after that, we also need to see the EKS OIDs here. Okay, so we want to communicate to this particular EKS cluster with a federated access. Right, for that region we need to have the OIDC enabled on this EKS cluster. Okay, so once you enable OIDC communication, in the sense you can communicate to your API server of your EKS cluster with using the federated identity. So here we are actually listing the TLS certificate belongs to our EKS cluster. With using that reference, we are actually constructing the OpenID connect for OpenID provider for our EKS cluster. Yeah. All right. So this is about the EKS OIDC. Now we have done with the lot many things. Let's go to the IAM driver. Okay. So we also need to create an IAM driver. That's where we are actually creating here. So as the name says, basically these are all nothing but the required IAM roles to communicate with the EKS cluster. So here we are actually having the we are actually creating the assume role policy. So remember that here we are actually creating the EKS OIDC identity provider. With using that identity provider, we are actually creating we are actually constructing a IAM role, and that is what I have kept in a IAM driver. So in this one, you see that this is a assume role statement. It is basically, you see that it has the assume role with the web role identity. Yeah. So likewise, basically you can see these code in a more details once you can go through this particular repository link which I have shared, and you can explore more about that. Now we are creating a the IAM role that is meant for EKS EBS CIDR purpose, right? And to that IAM role, we are actually attaching this this particular EBS CIDR driver policy. Okay. So now remember that this role EKS EBS CS driver role is a federated role. Okay. All right. So that's about the IAM driver .tf file. Now let's go back to our slide. So now we are done with the all prerequisite configurations, that is having the EKS cluster, creating the required drivers, required IAM roles. Now we need to deploy the components of the Istio, right? First we need to install the Istio application. Then we need to we need to then go to the next step, that is actually creating the Kubernetes objects that interact with the Istio Service Mesh. So as you see here, Istio Service Mesh can communicate to the Istio gateway, virtual service, and destination role. Okay, so basically they're all components of the Kubernetes that will help us to interact with the application, and those are all consolidated within a Istio Service Mesh. Let's see how to create the Istio foundational resources that is deployed on the EKS cluster. All right. So as I said, we need to create a Istio base and Istio D, the objects on the cluster, and through these objects, basically Istio governs the the complete management of the Istio Service Mesh. Okay. So here we are actually deploying the Istio base or basically Istio base component and Istio D component with using the Helm chart, right? So before you run this Helm chart, you need to have a prerequisite. What is that prerequisite? That is nothing but you need to have a Helm provider. So now what I'm doing is since I'm using the the Kubernetes to run the Helm charts or deploy the Helm chart. So before you run it, you need to have the access to your API server, or basically you need to have the context of your Kubernetes cluster. Then only the Helm charts can deploy the its application on the Kubernetes cluster. So for that reason, we need to get the Kubernetes cluster information, that is with using the data operator, right? Then here also you need to get the Kubernetes cluster auth. Then you need to create a provider for Helm, because with using this provider only the Helm charts can be deployed on the EKS cluster. So this is the syntax of creating the the provider for Helm. Now once we have the provider for Helm, we can go ahead and try to deploy the respective components. So this is the file which is actually deploys the Istio base. You see that. So here we have the the name of this particular Helm chart is something like this. Deployment has been Helm deployment or Helm release name is something like this. It is pointing to a repository. This is the repository. You see that. Note that Istio Service Mesh is been developed and designed by the Google, IBM, and another company. So those companies basically managing this repository, that is which is for community purpose. Yeah. So then this is basically this is a chart is base chart. This is a namespace. It's going to dynamically create a namespace called Istio system. It creates basically, since you are marking the create namespace equal to true, so it's going to create a namespace for us. The version of this Istio chart is this one, and then you see that we are actually setting the the certain configurations here. Yeah. So likewise Istio D. Okay. So remember that. So in the traditional days of Istio component, So there were like components like gallery, and there were like HCOD. So there were like a hell lot of components were there earlier to construct the complete Istio control plane. Now those all components are being wrapped into a single component called HCOD. So if you are releasing this HCOD component on your EKS cluster, nothing but your complete service mesh configuration is done. Okay, basically service mesh configuration is comprised of Istio base and HCOD. Right now, even the respective community providers are recommending you to deploy those components with using the Helm charts, and that's what we are doing it here. So it remains same as it is. You see that the chart name is here is HCOD, right? And the respective components are being set. You see that telemetry is enabled, global Istio name is enabled. These are nothing but properties that we're going to set it while we deploy the HCOD component on the EKS cluster. So with this one, so we are actually done with this one, and the one more is we're going to create a Istio gateway. So here, as I said, we're going to use the the Istio gateway for the communication from internet. Okay, so for that case we are creating a gateway as well. So we are also deploying the gateway that is meant for Istio component purpose. So Istio Service Mesh gateway is also being created here with using this particular component. Yeah. Now with that, I have another file reminder which I'm going to walk you through this quickly. That is nothing but our provider. So provider is basically, as it says, the name's provider. Okay, so if I go to the providers, so normal providers. Okay, so basically we have another reminder file which I didn't walk through. So basically this is where we are actually creating a AWS provider for Terraform, and we are actually declaring our region providers as well. Okay, so that's all about the our foundational components are basically infrastructure. Now we're going to run the the command that is Terraform init and Terraform apply. Now before you run this command, so you make sure that you actually set the context of your AWS account. I have an IAM role, and that IAM role has the admin access on my EKS cluster on my complete AWS account. Now I'm using that IAM user credential. Sorry, it's not an IAM role, it is IAM user. I have an IAM user. That IAM user has an admin privilege. Now I have created that IAM user secret and access key. With using that, I'm logging into the AWS account with using AWS CLI, that is AWS configure. Once I run AWS configure, it will ask you the access key ID. This is my access key ID I have given. This is my secret. And then the default region I'm setting is US West 2, where I'm spinning the infrastructure. This is the output format. Now with this configuration setup, you are actually set the context of your AWS account. In the sense, now you can interact with the AWS account with using the AWS CLI, or with using the Boto3 as well, or with using the with even using the OIDC provider, whatever you want to, right? So you can do it from here. Now to validate, you can do AWS STS get caller identity. So if you type this command, it actually has to return certain things, right? So here you go, right? So we are using the CI/CD user which has an admin privilege. So why did I show you this one is to make sure that you are aware that this is the prerequisite to run the Terraform file. Now with that being said, the context, now let's run the command called Terraform init. So once you run the Terraform init, basically it actually checks all the Terraform file that you have defined in this particular folder. Remember that, so your present working directory should be the directory where you have kept all your Terraform files, right? So we are done with that. Now let's go to the next command, that is actually Terraform plan. So in the Terraform plan, basically it does not spin up the infrastructure, but it actually creates a draft of the infrastructure that it's gonna spin up. Yeah. All right. So since I have already spin up the EKS cluster, it will not take any time, and it will show that the infrastructure changes would be 0 probably. Yeah. But if you are doing it for the first time, remember that it's going to take some amount of time for your information. So currently it is a live capture of the the demo. So I'm going to minimize this one while it is running. Let's go bit up, and here you go, right? So basically currently it is running. You see that there are no changes it has identified. Why it is saying? Because I have already deployed this infrastructure to my AWS account. Now let's run the final command, that is Terraform apply. So you need to do like this, Terraform apply auto approve. So now we are running the final command, that is Terraform apply, which actually spins up my infrastructure in the AWS account, right? So with this context, we are actually done with the the setting the infrastructure at AWS account. Now once the infrastructure is done, now let's go to the next component, that is actually deploying the application on the EKS cluster and configuring the service mesh component so that you govern the traffic of the service to service communication with using service mesh. Yeah. So currently let it finish, then I'm going to go to the next file. Okay, so we are done with this folder while it is running. We have another folder called Helm default. Okay, so as we saw, that I am deploying the Istio base and Istio default. So basically, these are all nothing but, the parameters of respective Helm chart. If you want to change, you can change it. If you don't want to change, keep it default. Right. So when you are changing, make sure that you pass this particular file as a parameter. Okay. Now that is the Helm default folder. Now let's go to the, our scenarios. Now let's say that I want to show you the two scenario here. That is, first one, let's explore user and first explore the service to service communication. Yeah. So for that sake, what we do is we're going to deploy an application, two application basically. One is client application, the other one is the normal application. How does this client application communicate to that, the normal application, which we're going to see it right away. Here you go. So we have run the Terraform apply, and you see that, there are no changes because my infrastructure is up and running fine. So if I go to my EKS cluster in the Oregon region here, go to the cluster. So I have a demo in, so the demo cluster, is up and running fine. It is in active state. You can go to the compute. We have a node group. So this is my node group as well. You can see that we have a node that is only one node will be there. Okay, so health services, everything is up and running fine. Okay, that is my infrastructure. Yeah. Now what I do is, I'm going to take you to the next step. That is, we're going to go back to the diagram here. Let's first try to understand how this client service try to communicate with the, the another application service, that is service 1 or service 2, for example, right? That is nothing but how does the service mesh manages service to service communication, which we're going to experiment now. So I'm going to do a cd dot dot now. Let's go to the next path, that is nothing but service to service communication. Right, so in this path, what we do is, we're gonna quickly see what is these files are, the manifest files, what is these manifest files are doing actually, in the sense. So as you know that, we actually deploy the, we actually define the objects of Kubernetes cluster in a specification file or in a declarative format, that is nothing but in a YAML format, right? So we're gonna see these declarative YAML files, which is basically called as a manifest file. Right, so first one, that is application version 1. Say that you want to deploy your application version 1. If I go back to the diagram, so this is our service, and that services contains two versions of services. One is application version 1 and version 2, like that. Yeah. Now, so how I'm defining that, app that, version 1. So this is basically an deployment object, or so when you know that deployment is nothing but, it basically creates the container in the application, or container, sorry, it basically deploys a pod into the Kubernetes cluster. So pod will comprises the container. So that's what I mean. So here we see that, we are actually deploying a component called deployment. So that has these metadata, and in the specification you see that, we are actually declaring that we need a one replica, we need these are the selectors. So basically these are all my selectors, like that we are actually declaring. And then in the template, we are actually labeling that particular deployment as SSS app, that is service to service communication app, and version is version 1, and Istio monitor, I'm just keeping it by default. And then in the specifications of the containers, right, underneath the specifications, we have another block called specification, where we actually point our application Docker image. So this is where my Docker image is coming, right? If I go back to the diagram, go back to the Docker hub, you see that the path of this is nothing, this one. So that is what, I have kept in this image, the pointing. So basically it does the image pull, and then the name is this one, that is nothing but we are giving the name to that particular container, like this, right? And these are the, basically the annotations, and this this pod will be listening on port number 8080. That's what we are defining. Yeah. So likewise, same thing for app version 2 as well. So it is also a deployment. It also has a metadata like same, and it has a replication 1. Then we have a selectors, we have a template, right? So we have within the template we have a metadata specifications. It is also pointing to the same application. Okay, so remember like that. But here you see that, it has a different annotation, something like that. All right, so basically this is nothing but, so when you have a very enterprise grade application and you need to manage the version of your application without affecting the user, that's where you're going to use the Istio, the capabilities to actually solve that problem of, having a downtime while you are rolling your updates, yeah, to the application. Okay, so rolling the update to your application or business logic. So that is my application version 2. Then we have a client. So basically this is what actually I call it as a client pod. So if I go to this one, so this is the client pod. It's a dummy container pod that actually helps us to log into that particular pod and try to reach this particular service. Okay, that's what I'm just creating one example pod here. So it will have its own namespace. You see that we are creating its own namespace, and we are actually creating a pod. Remember that this is kind is pod. We're just creating a pod, and then so basically underneath that we are actually creating a container, and the image is nothing but this is a curl image, which is default public image, and within that we are actually running this command. Okay, so basically we are constructing a pod through which I can run the some the bash commands like that. And then comes the the original components within the service mesh, that is gateway, virtual service, destination rules. Okay, let's see how we are doing with those. Now before that I need to go to the another two file, that is nothing but namespace. So we are creating a namespace called staging for this demo purpose, and we are actually wrapping those parts. Okay, if you see that I have did a two deployment of version 1 and version 2. So we are actually creating a service which actually wraps those version 1 and version 2 pods, right? And those pods are basically you are actually creating abstraction in front of those two pods, and that basically will be listening. In the sense we are actually call that abstraction as a service, and that service will be listening on port number 8080, right? And it is actually selecting the parts. So how does that service select the parts? By selector attribute, that is selector app. If I go back to the version 1, you see that the metadata label, the app label is nothing but you see that SSS app. So from by that annotation, the service will automatically map the basically group the the pods and construct a service out of it. So we are done with that. Now let's see that how are we creating the virtual service. So this is the basically this is actually, you see that the API version is coming from istio.com. If I go back to this one, so this is basically purely Kubernetes objects. But if you go to the virtual services.yaml file, you see that API version is coming from istio.com, that is version beta 1. So this is actually creating a virtual service within the Istio Service Mesh, and it is actually, it has lots of properties like metadata. So these are all metadata, and it has a specifications like other deployments. So it will be having the basically service, this virtual service will having a host, that is SSH app, or basically virtual service will be governed by a route. So that route definitions will be defined here. So it will say that hey, whenever somebody reaches to this particular virtual service, it will be governed by a destination rule, and that destination rule name is somewhere we are keeping here. And this is the place where actually control the traffic weight, in the sense when you have rolled out your application version 1 and version 2 simultaneously, you can govern the traffic to be routed in a weighted fashion. Say like 50% of traffic should go to this particular version, 50% of traffic should go to this particular version. So we can also mimic those scenarios. I will show you that how does that works in the demo. So that is what we will do in the virtual service. Remember, this is very, very important point. And the next one is final component, that is destination. So as we declared that the virtual service will point to a destination rule, that name is nothing but this is where we have defined. So don't get confused with the same names, but yeah, we use same names so that we avoid the confusion and helps us to do a less troubleshooting, reduces the complexity like that. Yeah. So next one is this is basically points to, so destination serve rules. If I go back to this one, so destination rule will point to a service. So this is nothing but a service. You see that the specification it is will direct to a service called, that is service to service communication application service. Then we have a subset within that destination rules. We have a two subset, one talking to the version 1, the other one is talking to the version 2, like that. Yeah. So this is basically you see that it will point to this particular the container. Within this SS service we have a container called, our application container called version 1. So that is where it will be routing. Similarly for version 2, like that. Okay, if I go down to this one, so when we're creating the container or basically container out of this image, we are actually annotating, in the sense if you see that we are annotating itself, that is version equal to version 1, like that. Yeah. So by virtue of that, the destination route can do a traffic routing to the services and to the versions of respective applications. Alright, so that is what it happens. Now time has come to do the deployment of this particular, and we will see how does the communication between the service to service will happen. So for that reason I will just open the readme.md file where I have written the certain commands which will help me. So we're going to run a kubectl command here. So before you run the kubectl command, you need to run a AWS CLI command called AWS configure, right? So we need to run basically we need to run this AWS EKS configure command. Okay, so if I need to go and search the AWS EKS configure, or basically update config. Yeah, so let's run this command, that is update config. So I need to run the AWS update config CLI command so that I can set the context. So let's use this command, that is I'm going to go to the update kube config. So why I need to do, because I need to run the kubectl command from my laptop, and for that reason I need to update my kube config file. So I can do the kube config file because by using the CLI command, that is nothing but like this. So I'm doing this one. So my cluster name, you see that my cluster name is just a demo. All right, so this is demo. And if your reason is different than the what you are did previously while you are running the AWS configure, you also need to provide the region as well. So now what we're doing is we're running a command called AWS EKS update config, update kube config. So basically it will update my kube config file. Yeah. Now we are actually done with the setting the context of Kubernetes cluster. Now I can talk to the API server with using the kubectl APIs. That is kubectl get pods, or say get nodes. So if I run the kubectl get nodes, so basically it is returning the nodes detail, which means that my kube config file is properly configured. Now I can run the command, that is kubectl apply -f dot. So what does this mean is, in the sense, it will recursively it will try to apply all these the Kubernetes specification file or manifest file and try to create the object as expected. So I'm going to run the command called kubectl apply -f dot. So what it does, it will just check whether these objects are created as expected or not. I have already created, so it will show you like this. You see that it is deploying the the application version 1, application version 2. It is creating the namespace backend. It is creating a pod called client. In the client, the namespace, and you have the you see that we also have the Istio object, that is you see that networking object destination rule also being created. Then we have a service, that is nothing but the Kubernetes service. We are having a namespace like this, and we also have the Istio application object, that is virtual service. You see that. So whichever the component that is belongs to Istio will be annotated like this. Yeah. So if you are running for the first time, you might get the error, because since we are deploying all the YAML file in one shot, so it might throw the error while running the deploy or creating the the Kubernetes object that are dependent on the namespace. First you need to create a namespace, then you create the other Kubernetes objects that are related to the actually related to the the namespace. Yeah. All right. So so that's what we are done with it now. Now we can try to basically simulate the service to service communication, because our pod is now running fine. So basically we have deployed the service, we have deployed the containers within that service. Now we can try to talk like this, in the sense, now we have set the gateway, we have set the virtual service, we have set the rules. Now we need to make this communication. Yeah. So likewise. All right. So let me go to the so now to simulate that scenario, I need to run certain kubectl command again. So I'm just gonna make this readme.file available here. All right. So let me make this like this. Yeah. So here we need to run we basically need to run the the client pod, and from there we need to run the curl command. Okay. Let's see how we can do that. So to do that, we need to run this command, that is kubectl execute -it, that is the pod name. That is okay. So if I can run the pod, so before I running the command, let me run a kubectl get ns or namespace. So we will see that we have so many namespace here. In that one, we need to see the staging namespace, get pod n staging. So we could see that there are the pods, in the sense we have application pod running in the staging the namespace. Now we're gonna do one more step, that is execute the this one like this. So basically what we are doing is we are actually taking the the SSH connect to the particular pod, that is pod that is created in a backend namespace, and the name is client. Yeah. Now we are in this particular pod, and we can do try to mimic the service to service communication. So what I do is I'm going to just run a command called hostname, so that you can see that what is a hostname. This is a client. Now what we do is we're going to run a command that is actually this command. Yeah. So if I try to explain this command, okay, so what this command is, this command will recursively run the curl command that is actually tries to talk to the the SSH app. Basically, if I go back to the diagram, so we are initiating the communication from this client server to this virtual service. From the destination, we're going to reach this, and we are doing this activity recursively. Why? So that I can show you that in the destination rule, we have, sorry, in the virtual service, we have said that hey, traffic should be distributed half of, okay, like that. Now let's see whether that will work. Yeah, so I'm going to run this command recursively, and you see that we are continuously hitting that endpoint, nothing but this is the endpoint now of our service or microservice. You see that traffic is now one time reaching to the version 1, another time it is reaching to the version 1. Okay, so this is the benefit of the service mesh. Okay, you see that this is what basically the service to service communication happening. Yeah, and this is actually the real time execution as well. All right, so I'm going to come out of this one. We're going to go to the next demo, that is how to talk from the internet to the service. Okay, so let me do an exit now. So we have seen the one scenario. Let's go to the another scenario, that is actually user to service communication, that is communication from internet to the service. If I go back to the diagram, let's mimic this, the traffic that is from client, how we are reaching to this particular service. So for that case, I have dedicatedly created another, we have dedicatedly created another folder called user to service communication. Let's go to the particular directory. Let's go to the cd dot, and we're going to go to this cd user service like this. Yeah, now I'm going to clear the output here. So we need to go through this file. So let me tell you that this is exactly same, but only difference is that here we will have an extra component called gateway, which is actually again a Istio component only. Okay, so if I go quickly, so this is again our same application, that is the app version 1. It is also pointing to the same the Docker Docker image that is stored in a Docker hub, and we are giving the here we are giving the name of the name of the Docker. Basically, name of the Docker container is something like starting with a UA -app. Instead of SS, here I'm using user application, something like that. Yeah, so that is basically application version 1. You can feel free to explore this file from the repository link. Yeah, so likewise for the app, the app version 2 as well. So if I try to show you again, so here we are actually having, you see that we are actually having a deployment. So both app version 1 and app version 1 2 are basically our deployments. Yeah, so we have a metadata here, we have a specifications. So it's going to create a replica of one pod. We have a template, we have a metadata. In the specification, we are actually pointing to this one, and here we are actually in the environment, we are creating the the annotations of versions, that is version 2. So likewise for version 1, it's just only the same thing. Here only one difference is version 1. Both will be listening on the port number 8080. Remember that. Yeah, so that is basically our two deployments pointing application version 1 and application version 2. Now we have to go to the next one, that is namespace. It is basically creating a namespace called production. Earlier we saw that namespace in a staging, now it is a production like that. Now we need to see the service as well. So basically this is a service which actually wraps the two parts, that is version 1 pod and version 2 pod. Both parts are being wrapped in front of a service, or basically those two parts are being abstracted by a service name called UA-app. Yeah, and that service is listenable on the port number 8080 HTTP. All right, that is about the service and namespace. Now let's go to the original component, right? So if I go back to the diagram, so we need to see how are we constructing the gateway component of Istio Service Mesh, and then how are we mapping that gateway to a service, virtual service, how the virtual service is in turn mapping to the destination. You see that all these components are communicating each other in some other way, and that is being happening because we are declining in the YAML files. Let's see how are we doing that. So if I go to that gateway, so this is, you see that this is component, this API version is coming from istio.com, or basically istio.io, and this is kind of gateway. So we have a metadata like this, specification like this. So this is selector is gateway, and here we have a servers. So server is nothing but basically a service. So what is a service? Basically you see that it is nothing but pointing to a dummy host, that is app.devopsexample.com, which I'm going to show you how to do that. So basically it is trying to hit this particular host or basically DNS of the service, yeah, and that is listening on port number 80. So if you go back to this one, so how this gateway reaching to this particular virtual services by host name, yeah. So if we go to the virtual service now, let's see, right? So here, as we explained in the service to service communication demo, so here it is pointing to the Istio.io version as well. This is virtual service. This is metadata information. In the in the specification, you have the basically you see that this virtual service has a host or basically DNS, you can call it, right? So that is nothing but app.devops by example.com, ua-app.com, like that. And then it has an API gateway that is nothing but the gateway is initiated by a API, nothing but it's a, if you know the API URL, those URL are having a resources divided by / API, like that. Yeah, you see that the HTTPS URL will be prefixed by / that is / API, like that. Yeah, in the destination, you see that the destination, it is governing to a destination rule, in the sense a service will have a route, and route is defined in a destination rules. The destination rule is another Istio component, and here we are actually this is pointing to a service. So destination is pointing to us basically it's pointing to a container, and this is the something like this. Yeah, so and you see that here actually I'm doing something different here, that is wait. So here basically we're actually saying that hey, whenever the traffic comes to this particular virtual service, do it in this wait format, in the sense route 10% of traffic to this particular version 1 application, route 90% of traffic to this version 2, like that. Yeah, you can change this based on your application demand. So that is the configuration of the virtual services. Now we go to the final component, that is destination. In the destination, as I said, this is where it actually routes the traffic, in the sense this is the final component which will dictate that this is how the traffic has to reach to the container, like that. So this is again created by an API version on Istio.io, and you see that count is basically the kind is here is destination rule. It has a metadata, like that. So you see that in the specification we are actually pointing to the host, nothing but this is Kubernetes service. From the Kubernetes services, underneath the Kubernetes services, I need to reach to this kind of the containers, like that, and that is being defined in the two subsets. One subset is meant for version 1 and the version 2, like that. So underneath that, it is dictating to the app. App is nothing but what? It is defined in a deployment, nothing but your container. Container is nothing but your application. That's where your application is running. Yeah, and that is where basically connecting that. You see that how these Istio components are being declaring those the Istio the Istio components which is actually interacting each other, and finally routing the traffic to the respective destination from the source to destination. Yeah, so I'm showing you very bare minimum functionalities of the Istio, but Istio can do more than this, right? There are a lot many things that it can do, right? So as you know that Istio service message helps you to identify the services, manage the traffic, right, and control the the basically control the traffic, and which by controlling the traffic is actually enhancing the application performance, like that. Yeah, all right. So now we have walked you through the user services. Let's run the next command, that is basically let's do a Terraform apply here as well. That is Terraform apply to all the path. Okay, so I have already deployed these components. Now let's see what it does. Okay, so basically you see that it is creating these many Kubernetes objects. So first one is it is deploying the your UA-app version 1, UA-app version 2. Then it is creating the Istio component, that is destination rule, a gateway Istio component, and then this is the Kubernetes object, that is service. We have a namespace, that is production, and this is the virtual service, that is Kubernetes basically Istio object as well. Now since I am running it for second time, so I am not getting any error. Since you are deploying the kubectl on the folder level, you might throw the error for the first time, because here the prerequisite is you need to have a namespace called production, then only the other components can be deployed. Okay, so when you are doing it for the first time, pointing to the particular the folder, you might encounter the error. Try running the same command again, it will go green. All right, so now with that option we are done with the the required deployment. Let's go to the final testing. Okay, so to test this I have created one command called something like this. Since my is a Windows Windows application, so before I before we actually experiment this traffic, that is traffic from user to the destination, that is service. Okay, let's see how we can do that. Yeah, so before that, let's identify our the endpoints. Okay, so to identify our endpoint, we need to do kubectl get service. Okay, so how I need to get the endpoint here? That is nothing but this application endpoint, that is nothing but our ALB endpoint. Okay, so how do I get that? By running the command, that is kubectl get service namespace. So basically namespace is that is, we have created that gateway. If I go back to the EKS and we go back to the gateway, Istio gateway, so it is being created in a namespace called Istio ingress. So you need to go to this particular path and try to do a ingress like this. So once you run this particular command, you see that it will show you the ALB link. This is what the ALB link, which we're gonna use it to communicate from the internet. So if I go back to this command, so I have two commands here. One is the command that is meant for doing a curl if you have a Linux command, Linux systems, and this is for running from the Windows. I have a Windows system, so let's try to reach my application from the internet like this. Okay, now I am not present in the Kubernetes environment. I am present in my laptop environment, basically considered as an internet. Now from the internet, we are running this command, that is nothing but invoking the HTTPS command to this particular endpoint, that is nothing but ALB endpoint. And then after that ALB endpoint, we are actually going to the API path, that is API/device. So device is nothing but your application resource here. Yeah, and then the header since I don't have the DNS register for this endpoint, so I'm keeping this endpoint in the header only, so that I can talk to this particular endpoint. Okay, so why I'm doing this one? That is where we have defined in the virtual service. Okay, so if you go to the virtual services, you see that this virtual services is listening on this particular host or particular DNS like that. Yeah, and just to bypass that, we are actually giving in a header. So if I run this command, you see that here you go, right? So I have got the response. So here you see that I have got a response like 200. Okay, and it is responding something like this. Yeah, and so basically what does this mean? It is basically giving me the required response. Yeah, so what does this mean is, if I go to the diagram again back, so our client can talk to this particular the application that is governed by Istio Service Mesh, in the sense our application service is now listening from the internet, which is governed by the Istio Service Mesh. Okay, so with that note, I have shown you the two scenarios and have gone you from 0 to basically level 5 or 6 on the how to manage the Istio Service Mesh on the EKS cluster. All right, so with that note, I have shown you the things need to be shown is a demo completely. Finally, a kind request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you, thanks a lot, and see you in the next video.